Lesson 6 focuses on parallel and perpendicular lines, and it's basically talking about the slope of parallel and perpendicular lines, and then how do we write the equation given some other information of a line parallel or perpendicular to a given equation. So first thing I'm going to talk about is the slope. So parallel lines have the same slope because they will never cross. So parallel lines have the same slope, or same slopes, and they'd have to have different y-intercepts. So the same slope means they're never going to cross, but they have to start at a different y-intercept, otherwise it would be the same line. So same slopes and different y-intercepts. So a picture of parallel lines would be two lines that never cross, and they have different y-intercepts. And then perpendicular lines are the other type of lines we would talk about. Those are two lines that intersect and they form 90-degree angles. So we would put this little half of a square in there to represent that those lines cross at a 90-degree angle. So perpendicular lines have negative reciprocal slopes, or the relationship. So negative reciprocal slopes. So essentially what that means is you flip and negate when you're talking about perpendicular slopes. So reciprocal, remember, means to take a fraction and to flip it, and then negative means if it's positive, it's going to become negative. If it's negative, it's going to become positive. So an example of a perpendicular slope would be like if I have 2, the perpendicular version of that would be flip it. So remember, any whole number is like over 1. So flip it, it becomes 1 over 2, negate it, it becomes negative. So these two slopes would be perpendicular. So let's look at this first example here. Given 2y equals 6x plus 12 and 3y plus x equals 15, determine if the lines are parallel, perpendicular, or neither. So basically what I need to do is I need to figure out the slope of the first equation and the slope of the second equation and compare them to see, do they have the same slopes? So are they parallel? Or do they have negative reciprocal slopes? Are they perpendicular, or is it neither? So what we're going to do is we're going to take each equation and we need to find the slope of each equation, which really means get it into y equals mx plus b form. Because if you get it into y equals mx plus b, you know that the number in front of the x is the slope. So to get this so that it's in y equals mx plus b form, I'm going to divide everything by 2. I need to get y by itself. So if those are gone, I have y equals 3x plus 6. So then looking at this, the slope of this line is going to be 3. It's the number in front of x. And then I'm going to do the exact same process over here. I'm going to go to 3y plus x equals 15. So I need to get this into y equals mx plus b form. So first thing is I'm going to subtract over the x. So I have 3y equals negative x plus 15. Again, make sure you keep the signs in front of the numbers or the variables. And it's always good to write it as mx plus b. That's just the slope-intercept form of a line. So I put the x first. And then I need to divide everything by 3 to get y by itself. So these cancel. I have y equals negative x over 3 plus 5. Now keep in mind, negative x over 3 is really a 1 with the x. So this is really negative 1/3 times x plus 5, because remember dividing by 3 is like multiplying by 1/3. So that means the slope of this line is really negative 1/3. So then when I compare these two numbers, 3 and negative 1/3, you ask yourself, what's the relationship? Well, they're not the same. So then I check, are they negative reciprocals? So did I take 1 and flip and negate it? So if I look at 3, which is really like taking 3 over 1, if I flip it, I get 1 over 3, and I negate, I get negative 1/3. So that means, yes, these are perpendicular because I flipped and negated the slopes. So these lines are perpendicular. because the slopes are negative reciprocals. We flip and we negated. So that's that first one. And for example, if I would have gotten out 3 1/3, then it would have been neither, because they would have been reciprocals but not negative reciprocals. So that can happen, so just be aware of that. So let's look at another example with parallel and perpendicular. So example 2, write the equation of a line that is parallel to this equation and it has the same y-intercept as this other equation. So parallel to this equation here means it has to have the same slope as this equation. So I need to figure out the slope of that, and then it has to have the same y-intercept as this equation here. So my goal here is to come up with an equation in y equals mx plus b form, because I'm going to be able to figure out the slope from the first equation and the y-intercept from the second. So I'm going to use slope-intercept form to write my equation, since I'm going to be having the slope and the y-intercept. So the same slope, let's go ahead and figure that out. So remember, when you're trying to figure out the slope, you want to get this into y equals mx plus b form first. So that means I need to bring the 4x over. So I have 2y equals negative 4x minus 8. Divide everything by 2. So we have y equals negative 2x minus 4. So when you look at this, you'll see your slope is what we want from this equation based on the directions of the question. So my slope is going to be negative 2. And then the y-intercept, it has to have the same y-intercept as the second equation. Negative 3y equals negative 2x minus 9. So we're going to divide everything by negative 3. So we have y equals, this is just going to become a positive 2/3 x, because it was a negative divided by a negative. Same with the end, is going to become a positive 3. So we wanted the same y-intercept as this equation. So the y-intercept is going to be 3. So then what I'm going to do is I'm going to write an equation that has a slope of negative 2 and a y-intercept of 3. So it's going to be y equals negative 2x plus 3. So then example 3. Given a line that is parallel to y equals 4x plus 5 and passes through the point negative 2, 4, write the equation of the line. So again, I want to write the equation of a line, and you can pick the form. You can pick point slope form, or you can use y-intercept form. But based on what we're given, we want to be parallel to this equation, which means I need to have the same slope as that equation. And it needs to pass through this point. So since I'm looking at something with a slope and a point, that means I'm going to want to use point slope form. Where the previous problem, I was given something with a slope and a y-intercept, which is why I used the slope-intercept form of a line. So for this one, it'll be more convenient to use the formula that we learned in the last lesson. So this is the point slope form. So I'm going to go ahead and I'm going to plug in the slope and the point. So my point is going to be the x1, y1. The slope, if you look at this equation, it's already in y equals mx plus b form. So I can just use that 4 as the slope. And we can just go ahead and plug in. So I have y minus 4 equals the slope of 4 times x minus negative 2. And then we're going to go ahead and simplify. So I'm going to have x plus 2 inside the parentheses. And you could, stop there and say it's done. I'm going to go ahead and I'm going to distribute. I always like to get my final answers in y equals mx plus b form. So we have 4x plus 8. Add the 4 to both sides. So we have y equals 4x plus 12. So this is an equation of a line that's parallel to this given line, 4x plus 5, and it passes through the point negative 2, 4. So since we plugged in the point negative 2, 4, we guaranteed that that point will lie on this line. We made it a solution to the equation. So let's look at just a couple more examples. So example 4, what is the equation of a line that is parallel to y equals negative 4, and it has to pass through this point? So again, we're given something about the slope because if it's parallel to this equation, it means it has to have the same slope as this equation, and it has to pass through this point. So when you look at this equation here, it's a y equals negative 4. So you kind of want to think to yourself, well, what does that really look like? So y equals negative 4. Well, what that's saying is y is always negative 4. And x can be anything we want. So it can be negative 1, 0, 1, 2. It can be anything you want. So what ends up happening is y equals negative 4 is going to be a horizontal line through negative 4. So if this is your x and y axis, this would be the line y equals negative 4. Remember, they're always opposite. The equations of lines are always opposite the axes. So since y is a vertical axis, y equals a number is going to be a horizontal line, because along any point on that line, y is always equal to negative 4, but x is changing. So the slope of this line, we know that the slope of any horizontal line is always 0. So that means the slope has to actually be 0, and it needs to pass through the point 3, 7. So again, you can use point slope form because you're given a point and you're given a point and you're given the slope. So I can go ahead and plug in all my information. So I have y minus 7 equals 0 times x minus 3. And what's going to happen with all of this stuff, it's just going to end up being 0, because 0 times anything is 0. So we're going to have y minus 7 equals 0. Add 7 to both sides, and you get y equals 7. So that's like algebraically. These examples, though, I almost think are sometimes easier just to think graphically, because since it's a horizontal line, y equals negative 4, if I need to be parallel to that, that just means I'm going to have any other horizontal line, and it's just going to have to pass through this point. So what I would do is I would plot the point 3, 7. So I would plot that point, and then what I would do is say, okay, well, in order to be parallel to the line y equals negative 4, it's just going to have to be a horizontal line through the point 3, 7, which is the same thing as saying y equals 7. So that's just another way of thinking of it. It's up to you how you want to go about it, but same concept would apply to like a line that said x equals a number. Or if it says that you have to be parallel to the x-axis or the y-axis. Think of it graphically, because you're dealing with undefined slope versus 0 slope for those. So you just kind of want to make sure you're aware of what it would look like graphically. So let's look at one last example here. And this is what happens when we want to write an equation that passes through a point, but it's now perpendicular. So we want to pass through this point, and it needs to be perpendicular to this equation. Negative 5x equals 6y plus 18. So what we're going to do, perpendicular means it's going to be flip and negate for the slope. So again, we're given a point, and we're going to be given something about the slope, which means I want to use the point slope form of a line. So I'm going to start with my equation, negative 5x, and I'm going to get out the slope from that line. So I need to get this in y equals mx plus b form. So get the y by itself. So let's subtract 18 from both sides. So I have negative 5x minus 18 equals 6y. Divide everything by 6. So I have negative 5 over 6 x minus 3 equals y. So in y equals mx plus b form, y equals negative 5 over 6 x minus 3. So the slope of this line is negative 5 over 6, which means the perpendicular slope, so this is the perpendicular symbol, I'm sure you've seen it before, the upside down T represents perpendicular. The perpendicular slope means flip and negate that. So if I flip it, I get 6 over 5. If you negate a negative, it becomes positive. So this is actually going to be the slope I'm going to use. And when we use that slope, we're going to be plugging it into point slope form. So the point slope form of a line is this formula here. So we're going to go ahead, we're going to plug in our x1, y1. So I have negative 2 getting plugged in for y. My slope, remember, was 6 over 5. And I have x minus a negative 1. So first thing I'm going to do is I'm going to just change these to plus 2 and plus 1. Remember, you don't have to show this in between step. You could jump right to that. And then what I'm going to do is I'm going to distribute. So I have y plus 2 equals 6/5 x plus 6 over 5. Last step, subtract 2 from both sides. So I have 6 over 5x plus 6 over 5 minus 2. So this is how I think of these kinds of problems when you have a fraction minus a whole number. Think about how I can write 2 so that it has a denominator of 5. So basically, I can think of this as minus 10 over 5 because negative 10 divided by 5 is negative 2. So negative 2 is equal to negative 10 over 5. I wanted a common denominator of 5, so that's why I did that. So then what you're doing is you're going to keep the denominator of 5 and you're going to subtract the numbers up top. So 6 minus 10 gives me negative 4. So this is going to be a negative 4/5 as a y-intercept. And that would be your final answer. So that's it for writing equations that are parallel or perpendicular to a certain equation passing through a specific point, or some other scenario where you have to use parallel and perpendicular.